Okay, so the subject right now is reflections across the line y equals x. And we're actually going to do two. We're going to do reflections across the line y equals x and reflections across the line y equals negative x. So just like any reflection, the line of reflection that we're going to be going across, we want the points to go directly across the line. So that it'll go directly across, not at an angle, um, but well, at an angle, but it'll be at a 90-degree angle, straight across. And so the this point right here, point C, will go directly across 90-degree angle, and it'll be equidistant, so the same distance on either side from the line of reflection. And this line of reflection is line y equals x going across this way. So this is line y equals x. And one way of doing that reflection is by folding it. So this is, I'm going to use this clear plastic so you can see what exactly is happening. So I'm going to fold it along that line. And when I fold it across that line, notice what happens to this axis. It will go and it should end up on the vertical axis, on the y-axis. So if I do this correctly, it lines up perfectly. And it's not exactly perfect, but it's pretty close. And you can see what happened to this part. So we didn't reflect the whole thing. We only reflected this part right here, okay? In order to get the whole thing, we have to get the other part. And what will happen is we'll end up with something that looks like that. Okay. Now, if you'll notice, if you take a look at the corresponding points, this is A prime. And that's A. So this distance from here to here, this distance should be the same distance as this distance. And if you look at the straight line that goes directly across, it's a 90-degree angle. It forms a 90-degree angle going across from there to there. Okay? Now, I want you to also notice the points. This is -1, 3. This one is over 3 down 1. So if you look at the values, the coordinates, okay, all that happened is the coordinates switched. So this is -1, 3, this is 3, -1. We could have found that same exact point by counting. Now the way you count in this case here is, well, I could have drawn it in first. If you go to the line y equals x, I'm going to draw it in real lightly. So if you go to the line y equals x, you go either straight over or straight down, and then over the same distance. So I'm going to go 1, 2, 3. Now that's on the line of reflection. Hopefully you can see it. It's very light. Okay, so I'm going to go over 3, 1, 2, 3, 4, and then down that same amount. So I went over 4, so I'm going to go down 4. 1, 2, 3, 4. And that's the point. As you can see, it's right on top. Okay? We can find all the other points using the same method. So this one, if we go up here, that's 1, 2, 1, 2. This one right here, it would be 1, 2, 3, 4, 5, 6. Then that means we have to go up 6. 1, 2, 3, 4, 5, 6. So these 3 points should be the points that we have. Okay, so 2 ways of reflecting the line y across the line y equals x. One, you can use the rule in coordinate notation. Whatever you start out with for x and y, all you do is you switch. So -1, 3. Okay, so in our in the x location, the x coordinate, the new x coordinate will be the old y value. So that will be 3. The new y value will be the old x. That's going to be -1. That's the value right here. 1, 2, 3. Okay. So that's how you find the reflection across the line y equals x. For the line y equals -x, it's almost the same. Now, well, it is the same. The rule is slightly different, but the method where we're going to be counting to the line or flipping or folding it is exactly the same. So here, okay. So just like before, we want to fold that across the line. Now this time, the line y equals -x is going down to the right. So this is the same idea. All we're going to do is we're going to fold it. Now the last one was maybe a little more complex reflection because the triangle straddled or went across the line that it was being reflected across. Here it's not. It's all on one side of the line y equals x. So that means when we fold it, the whole triangle goes from one side to the other. And so it's going to fold over like that. And you can see that's the pre-image, that's the image. Now, if you look at it closely, you should see that it forms a 90-degree angle with the line of reflection, and it's the same distance on either side from the line of reflection. Now, it doesn't matter which point you're looking at, which pair of points I should say. A 90-degree angle right here. This distance right here, same distance as this. Okay? Now, if we look at the points here, okay, this one came from A, right? So this is A prime. And this is 1, 2, 3. Negative though, and +1. So on this one, we went from -1, 3 to -3, 1. So if you look at how we had the original, we're going to start off with x, comma y. It's going to be very similar to this. If you'll notice, we have the one, that's value of 1 is here, right? This is your x coordinate. Here it switches to the other side. So just like above, we have y and x switching roles, switching places. However, the signs are now different, right? So whatever x was, so x started out as -1, now it's positive. So we changed that sign. But we didn't just change that sign, we also changed the y value. So the y started at +3 and went to -3. So this is your rule. So the rule for reflecting across the line y equals x is xy to yx, and the one for the line y equals -x, reflecting across that is xy x comma y to negative y, negative x. Once again, a reflection can be thought of as a flip, and you can flip it by folding. That's what's happening when you reflect. Okay? If we were flipping across the x-axis, then it would just go like that. So it's a flip no matter which one you're doing. I hope that helps.